Bad. We're going to take absolute value equations, which we did 2 weeks ago, and inequalities, which we've been dealing with for about a week and a half, and we're going to mash the two together. It's not that bad. It's one of the last new topics we're going to talk about until we take our test over Unit 2, which we'll be doing next week. So I really wanted to try and squeak Unit 2's test in before the end of the quarter, but I wasn't able to. Unit 2's test is going to be right after the quarter. Yeah, quarter ends on Friday.
Really?
Awesome. Okay. So, yeah, no, quarter ends on Friday. All kinds of goodness. And then also this weekend you guys get another 3-day weekend because on Monday is parent-teacher conference meetings. Quarter ends Friday. Okay, shh, quiet. Quiet. All right. So, let me show you what absolute value inequalities look like. Tomorrow we're going to be talking about word problems that incorporate everything we've been dealing with so far. And then on Thursday we have a quiz. And then we're going to, on Thursday, also talk about some more complicated versions of those mixture problems. And then Friday we're going to start reviewing for the test, which will be next week. So, absolute value inequalities, what these look like. So let's take them pretty simple here. Let's do, I'm feeling M today. So let's do M plus 9 inside the absolute value. Let's start pretty simple here. And let's do greater than or equal to 15. So this is an example of an absolute value inequality. So it's just like an absolute value equation. It's just instead of having an equal to here, bless you, it has an inequality. In this case, I used greater than or equal to. Now, in order to solve this, we're going to need to graph it because we're going to have more than one possible solution to it. Now, just like with absolute value equations, we're going to split this up into two different parts. When we split it up into two different parts, though, we have to be really mindful about what happens to this inequality that's in the middle here. So please pay attention to what I'm about to do. So what I'm going to do is I'm going to pay attention to what happens to this middle part when I'm splitting it. So 1 is going to be m plus 9. And I'm going to keep this exactly as it is, so greater than or equal to. And the number on the right stays the same, 15. The other one is going to be m plus 9. And I'm going to make the number on the right be negative 15, just like with the absolute value that we were doing. But because I changed this number to be negative, because I changed the sign of the number, I need to flip this inequality around. Okay? So instead of this being greater than or equal to, now it needs to be less than or equal to. And then from here, it's the same thing I've been doing. I'm just going to solve these two inequalities. So, and I solved them both the exact same way. On the left-hand side, I would subtract 9 from both sides. So, subtract 9. This is going to be m greater than or equal to 15 minus 9 is what? 75? Okay, so that sounds better. 6. 75 sounded a bit off. And then on the one on the right, I'm going to subtract 9 from both sides. And then this is going to cancel. And then negative 15 minus 9, what does that turn into? Close?
24.
Negative 24. So I've got m is less than or equal to negative 24. All right.
It's pretty much the same, just it's not equal to, and then you have to flip the sign.
Right, and I'm going to show you one thing about the way that the arrows point here too. So I picked these two numbers that are kind of far apart, 6 and negative 24. So I need to be able to accommodate both of those on my graph here.
Count by sixes.
I'm going to put negative 24 here, way down here. I'm going to count by, sure, we can count by, let's count by 6s, why not? So here's negative 24. Let's do negative 18. If you counted by something else, that's fine. You count by something else too. You do you. Negative 12, negative 6, 0. Here's 6. All right, cool. So negative 24, I'm going to put a dot there. I'm going to fill it in because there's the equal to. Positive 6, I'm going to put a dot. I'm going to fill it in because there's the equal to. Now I'm going to look at these two individually. So my variable's on the left, so that means whichever way the inequality points, which is to the right, is the way the arrow is going to point. So at 6, my arrow is going to point to the right. Right? At negative 24, my arrow points to the left here, which means my arrow points to the left. Now, this is going to kind of feed into the inequality up here. So, with absolute value inequalities, and this is a big thing for your notes here. So if it's absolute value of, I don't know, something, and I'm just going to put like a scribble in here. So if the thing inside the absolute value is greater than, say, a number, and I'll just put like 10 here just as a number. This is just a number. Then your graph is going to have two things that point away from each other if it's greater than. I'm going to use else, which is a little piece of logic that you guys are going to learn all about next year in geometry or computer programming if you ever do anything in computer programming. If I'm going to do absolute value symbols, a little scribble there just to say something inside the absolute value. I'm going to do less than, I'm going to do some number over here, just say 10 again. If it's less than, instead of pointing away from each other, how do you think they're going to point? Towards each other, which means that they're going to make this line in between them. Kind of, sort of?
You betcha.
Maybe? Okay, let's try one from your assignment.
Uh-oh.
Well, no, you shouldn't say uh-oh, because if we do one from your assignment, that means that's one less that you have to do on your own. Like,
That is true.
that shouldn't be uh-oh. You should say uh-oh if I'm trying to come up with them off the top of my, like, that's when it should be uh-oh.
Uh-oh.
Now.
All right.
Uh-oh, we're gonna get, like...
Yeah, you're gonna get like decimals and fractions and stuff if I have to come up with it off the top of my head, especially on like on the first day back from a 3-day weekend. Okay, so let's do absolute value of 3x minus 7, absolute value greater than or equal to 11. So before we even go any further, first thing that you should do is stop and put your brain in for low. Get yourself some traction, right? This is muddy ground. This is like, you want to get yourself some traction, make sure that you're getting yourself some good footing. Should your graph, when you're finished, should it look like the top one or should it look like the bottom one? Okay, what Michaela says it should look like the top. Does anybody agree with Michaela that it should look like the top? Raise your hand if you agree with Michaela it should look like the top. Okay, Elijah and Gareth, you guys got to weigh in on this. Do you think it should look like the top or do you think it should look like the bottom? Okay, raise your hand if you think it should look like the top again. Okay, raise your hand if you should, put your hands down. Raise your hand if you think it should look like the bottom. Okay, so it should look like the top. So good on you if you guys think that. All right, so now the next thing we should do is split this into two separate equations here, all right? So Riley, what should one equation look like?
3x minus 7 is greater than or equal to 11.
Perfect. Nathan, what should the other equation look like?
3x negative 7 is greater than negative 11.
Okay, I agree with the negative 11, but instead of being greater than or equal to, we're gonna flip it around to be less than or equal to. And the reason we have to flip it is we change the sign of this. Okay? In absolute, or not in absolute values, in inequalities, when you change the sign of things, we need to flip the inequality.
Okay.
Okay. So now from here, we're just solving the thingy thing with the thing and the two things. It's okay. Nouns aren't my strong suit. So Michael, do you want to solve the one on the left or the one on the right? Spoilers, one of these will have a fraction as an answer. Mm-hmm. The one on the right. You sure? Oh, no, you said right. You can't go back now. So, Michael, how do you solve the one on the right?
You add 7.
To both sides.
Yeah.
So, what do I write down after I add 7 to both sides?
3x is less or equal to -4.
Perfect. What next?
You have to divide by 3.
divide both sides by 3. So divide by 3, and I get what to write down on my next line?
X is less than or equal to 7,500.
No,
Negative 7.
that's not what 4 divided by 3 is.
Oh, 1 and 3 would be 1.
Negative 1 and 1/3. Don't forget about the negative.
Oh,
So if you wanted to do or negative 1.3 repeating, but don't forget about the negative part.
Negative 1.
Okay, the one on the left here, Emily, how would I solve the one on the left?
The one on the left.
Mm-hmm.
Let's see what that is.
Does that help?
X is less than or equal to negative 1/3.
That's the right.
Oh, I'm blind. Sorry.
This is the left.
You would add 7 to those. No, yeah.
It's the same steps, yep. It's the same steps, you're just going to get different numbers. So you add 7 to both sides. Okay, and now what?
And then you would solve for, you would divide 18 by 3.
Okay, so I get 18 over here, greater than or equal to 3x, and now I'm dividing both sides by 3. Okay, so now I got x greater than or equal to, and then what's 18 divided by 3? 6. So if you're going to graph this now, you're going to have both 6 and negative 1 and 1/3. So I'm going to put 0 kind of here. I'm going to count by 2s, because why not? We'll go 2, 4, 6, we'll go up to 8. Sure, goes from 6 to 23 if we're counting by 2s, because that's how it works.
Yep.
We'll go negative 2, negative 4. Now, negative 1 and 1/3, I'm going to have to kind of eyeball it. Between what two numbers on here is negative 1 and 1/3?
Negative 2 and 0.
Between negative 2 and 0, right? Now, I'm not going to be able to be perfect on this, so I'm just going to kind of guess that negative 1 and 1/3 is between negative 2 and 0. It's a little more than halfway, so I'm going to put a dot there. Should I color it in?
yes.
Yes. And then I'm going to put my dot above 6. Should I color that dot in?
Yes.
Okay. And then, based on what Michaela said up here, should they be going together, or should they be going apart?
Apart.
Apart.
Should they be?
Ta-da! Okay, not so bad, right?
I think so.
All right. So let's try some of these together.
Why would they be showing apart?
So you're looking for absolute values that are greater than, which means that you're looking for numbers that are either greater than 6 or less than negative 1 and 1/3. Because if you substitute those values in, their absolute values are going to be bigger than 11. Because you need to have numbers that are going to give you an absolute value that are bigger than 11, which means that it needs to be.
Did you know there's no absolute value or negative absolute value?
There is no absolute value that is going to be equal to negative because absolute value is distance.
I
There's
got
no such
Panther
thing as
buck.
negative distance.
I got Panther buck.
Yes, you did. That was the whole point of Ferris Bueller's Day Off, is there's no such thing as negative distance.
What?
Have you ever seen that movie, Ferris Bueller's Day Off?
No.
Yeah.
The whole point of that movie is that there's no such thing as negative distance.
I think we should watch it just to.
What movie?
We're not going to. But the whole point of that movie is that there's no such thing as negative distance.
What's the movie?
Ferris Bueller's Day Off.
That sounds like a stupid show.
Okay. So,
You sound
now,
like a stupid person.
let's take a look at question number 1. So first thing we're going to do is we're going to split it into two different inequalities. The first inequality is the absolute value of b plus 7 is less than 7. Or sorry, not absolute value anymore. And then the other one is going to be b plus 7. And then on the other side we've got negative 7, but instead of being less than now, what's it going to be? Greater than. Perfect. Right? So let's see. Megan, how would I solve the one on the left?
You would subtract 7 from both sides.
So minus 7. So I have b is less than what?
0.
Perfect. And see, test. how would I solve the one on the right?
You would have to.
And I'd have b is greater than what? Nice. And Annabelle, at 0, would I color in that dot?
No.
At negative 14, would I color in that dot?
No.
And based on the way it looked at the beginning, would those two dots go together or would they go apart?
Okay.
No, take a look at your notes.
Together.
Yes. So you're just guessing 50-50 because you knew it had to be one of them and I said it wasn't the first one, so you knew it had to be the other one. But seriously, look at your notes. So if it's absolute value and it's the less than, if the Pac-Man wants to eat the number, then they go together. If Pac-Man wants to eat the absolute value, they go apart. Okay. So, alright. So next one, Steve, what are the two equations we're going to make? And? Alright. Which one do you want to solve, Steve? How do I do that? And p is greater than? Perfect. Elijah, how do I solve the right one? Not 90, but and I get p is less than. Great. So Cade, when I put a dot above positive 9, do I fill it in? Or sorry, Elijah is what I meant to say. And then Elijah, when I put a dot above 9, do I fill it in? Oh, sorry, thank you. Elijah, when I put a dot above 9, do I fill it in? Okay. Elijah, when I put a dot above negative 9, do I fill it in?
No.
Okay. Then based on the original Elijah, should they go together or apart?
Apart.
Okay. And sort of? Alright. Okay, two equations here. Christina, what are the two equations for number 3? And? Nice. How would I solve the one on the left? Okay. So I get 7x on the left and what on the right? 42, I think? Cool. And now what? And I get x is less than what? Michael, how would I solve the one on the right? So I get 7x is greater than. Cool. And what next? Well, it's going to be fraction or decimal. So x is greater than how many times? This one's going to be better if you do it as a fraction. It's going to be easier if you do it as a fraction. Yeah. Negative. Negative 8 and 6 7. So we're going to put our dot at 6. Don't fill it in. And then negative 8 and 6 sevenths. Here's negative 8, negative 9. You're not going to be able to find exactly negative 8 and 6 sevenths. You're just going to have to eyeball it. And then based on the original, should they go together or apart?
Together.
Okay. I love that you had a 50-50 shot there. And when I tell you the first one wrong,
I know it's the other answer.
Yeah. Okay. But you get it happens.
How can I move it from here?
Because you're closer to the
I'm not even.
Maybe it was Casper. It was Casper.
With a clown.
Cool.
It's okay.
Okay, guys, see this? I'm not touching it and it's moving.
It's okay. It's okay.
It's probably the board moving.
It could be. Who knows?
Hey, Charlie, the board.
He said probably.
Oh, okay.
It's okay. We ain't got to be mad.
I can fix it.
It's okay. Shh. Quiet. Quiet.
Angry spirit.
Quiet.
I'm not even doing anything.
What you doing right there?
Shh, quiet. Nathan, shush.
Oh, this is weird. We're gonna die.
I have no idea what's causing this to happen.
Just do it like that.
Okay, well, that's weird. Okay, I'm going to stop the